Ever noticed your player just stick to the wall like glue, or your wall jump feels completely off? That's usually not your jump, it's your wall logic. So today we are fixing that with clean system, precious detection, smooth sliding and wall jump that actually feels right. We will build this step by step, starting with wall detection, then adding smooth sliding and finally a responsive wall jump that feels natural to control. To start with, let's declare everything we need for our wall system. Under our wall jump functionality header, we will first create transform called wall check. This is just a point near the player where we will check for walls. Next, we define a wall check distance, which controls how far we want to check for a wall. Then, we add a layer mask called wall layer, so we only detect actual walls. Now, for the movement part, we define wall jump force X for horizontal push and wall jump force Y for vertical lift. We also add wall slide speed to control how fast the player slides down the wall, and wall jump time to control input during the jump. To track what's happening, we use 3 booleans: is touching wall, is wall sliding, and is wall jumping. Now, there is one more important value: facing direction. This simply tells us which direction the player is facing. If the player is facing right, facing direction is 1. If the player is facing left, it becomes -1. We use this value to make sure our wall detection always check in front of the player, not behind. Now that everything is set up, let's actually detect the wall. We will create a function called checkWalls. Inside this function, we use physics2d.raycast to shoot a ray in front of the player. And here is where facing direction becomes important. We multiply it with vector2.right, so the ray always points in the direction the player is facing. So if facing direction is 1, the ray goes right. If it's -1, ray goes left. If that ray hit a wall, we store that result in is touching wall. So the key is keeping this value accurate at all time. To do that, we update facing direction inside our flip logic. So this function basically answers one question: is there a wall in front of the player right now or not? That's it. Now that our direction is reliable, let's visualize what's actually happening. Inside on draw gizmo, we draw a ray in the scene view, so we can see our wall detection in real time. And to make this work during gameplay, we simply call checkWalls inside update. Now let's quickly set this up inside Unity. Create an empty object called wallCheck and position it slightly in front of the player. Usually around chest height works best. Then assign your wall layer so the raycast know what to detect. Now if we move near wall, you can see the ray hitting in the scene view, which means our detection is working perfectly. Now that wall detection is working, let's use it to actually create a slide. We will create a function called handle wall slide. The logic here is simple. If the player is touching a wall, not grounded, and moving downward, we enable wall slide. Normally, gravity would pull the player down at full speed, but instead, we limit that full speed using mathf.max. So the player slides down slowly instead of dropping instantly. Now let's call this function inside update. And here is an important improvement. Instead of using velocity, we use player input to decide the direction. Because velocity can be unstable, especially when the player touching uneven walls, and that can cause the character to flip back and forth. But input is consistent, so using it makes our direction stable and reliable. And that stability is exactly what we need for our wall detection to work properly. Now if we test this, you can see the player smoothly slide down the wall. Now that sliding feels good, let's build the wall jump on top of it. Inside handle jump, after checking our jump buffer, we give wall jump higher priority. So if the player is sliding on wall, we will perform a wall jump and return immediately. Now we haven't created this function yet, so let's do that. We will create a new function called PerformWallJump. Inside PerformWallJump, we first set is wall jumping to true, so we know the player is in wall jump state. Then we trigger the jump animation and reset our jump buffer and coyote time, so this jump doesn't conflict with our normal jump system. Next, we calculate the jump direction using negative facing direction, so the player always jump away from the wall. And finally, we apply velocity. Horizontal force pushes the player away from the wall, and vertical force gives the jump its height. Now, if we test this, the jump works, but there is a problem. If we keep holding the movement input towards the wall, the player snaps right back to it and completely killing the jump. So now we need to fix this behavior. To fix this, we use isWallJumping to temporarily disable input. We already set it to true at the start of the jump, so now we just need a way to turn it off. We create a function called stopWallJump, and inside it we set isWallJumping back to false. Then we use Invoke to call this function after wall jump time, so the player regains control after a short delay. And just to be safe, we use cancel invoke so multiple timers don't overlap. Finally, we stop our flip logic while wall jumping by returning early if isWallJumping is true. Now this part is completely optional. It depends on how you want your character to behave. If you want your player to keep facing the wall during the jump, you can simply leave it like this and ignore the next step. But if you want the player to instantly face away from the wall, you can manually call your flip function right after applying the jump force. And lastly, we block our movement code while wall jumping. This prevents player input from interfering and allows the physics system to handle the jump part cleanly. Now everything is working together. Smooth wall sliding and clean wall jumps with the proper arc. This gives you a solid base for your wall mechanism moving forward. If you found this useful, hit like and consider subscribing for more game dev tutorials. See you in the next one.